Hello, Community Grade here. Today is the 25th of June, and here I am with my science experiment that is investigating viscosity of liquids. What I've done is I've got three same bottles here, and I've drilled some holes of different apertures in each of them. We've got 11 mil, 7 mil, this one has tape on it, I'll explain why later, and 3 mil. Firstly, we're just going to start with one of these bottles. These are kind of an extension on this for students who may enjoy that. So I'll put these to the side for now. Okay, so what we've also got here, so these are our independent variables. We've got liquid hand soap, rice bran oil, or whatever, and this is water that I've just put a bit of green food colouring in so it shows up a bit better on camera. The other things that are important to have for this is a level surface. I've done my best today with the situation I'm in. I think it's level enough to not interfere with this test, which is fantastic. So these are independent variables. The dependent variable is the time it takes for the water to flow out the hole. So what I've done actually is I've marked a fill line for every bottle, and I've also marked a line to stop timing, which is above the hole in the bottle, which is around here on this bottle. I've taped it so I can fill the bottle up. I'll show you later. The reason why there is a stop line to stop timing instead of waiting for the water to drain all the way out is because as the water approaches the hole, the surface tension of the liquid is going to start playing a factor, and that's another variable that we're just not testing today. So just to keep this experiment simple and clean, we're stopping before the effects of that can be seen at the bottom there. So I've taped the hole up so we can fill this up, and we're going to start with water. And the other equipment we need is a stopwatch. I'm filming this on my phone, so I'm going to use my wristwatch and pencil and paper reporting data, or a pre-done sheet, which is a part of this lesson, which basically is a little grid. This is just everyone, but the real one will be typed up. Water, soap, oil down here, and across the top we've got test 1, test 2, and test 3. And this is where we'll write the times. So without any further ado, let's get underway. So I'm going to start by filling this bottle up to the fill line with the water that has been dyed green. Oops. Now this should be the right amount of water because I somewhat measured it earlier. It's a little less, which is okay because I've just got a little extra water here to fill up right to the fill line. So just a little bit more water there, and I can see that's at the fill line now. So there we go, and we'll put this up on here on our little podium. I've got our baking dish to catch the water so that I can repeat the test. I want to do it about maybe 3 or 4 times for each liquid, say 3. And I think this would be probably good for students to do in pairs or groups because there's a little bit of multitasking here that needs more than one set of hands. Basically, we're going to start the water flow by ripping the tape off. And so, one student on a stopwatch, maybe another student ripping the tape off, and maybe another for observation, just depending, it's a bit flexible. So I'm going to just put my stopwatch up here and zero it. There we go. So I need to take this tape off and start my stopwatch at the same time, but because I only have 2 hands, there will be a little bit of discrepancy, but we'll do our best. Ready? 1, 3. And so the water, you can see that coming out. It'll start in a more powerful stream, and as the water level drops, as you can see, it slows down. So I hit stop when it hit there, and I've got 11 seconds. So I can write that down in the water test 1, 11 seconds. And as you can see, as the water has approached the hole, it has definitely started to behave a little bit differently. I liked the reason I didn't put the hole in the bottom of the vessel, which would have gotten rid of that extra thing, is because I really wanted students to be able to see it come out for the demonstration reason. And also I think it's okay to leave those little clues about other science phenomena that might be happening there, because it's great to leave those breadcrumbs for future concepts to explore, and whether that's in this lesson as an extension or whether that's in years to come down the track in science. So I think that's pretty cool. So that's finished draining out, so I won't repeat each test a number of times for the sake of this video. I'll just move on to the next liquid. But it's important to keep the same bottle because that is a control variable with the same hole and everything, and the same surface and blah blah blah. We don't want to introduce any more variables. So what I'm going to do is get a new piece of tape. And you want to just tape that on real good there, leaving a little tab to make it easier to pull. And I will clean this vessel up. So, because I know that water is the least viscous out of all these materials, I mean liquids, my mistake. I know that the other two liquids are probably not going to shoot as far, so I'm reasonably confident that I'm not going to make too much of a mess. So now we'll start with the soap. So this is going to probably take a bit. Now we've got the same bottle, we've got it filled with liquid hand soap, nice and red. And we're going to do the same test. So I'm going to just zero my stopwatch. Yep, and here we go. Put this bottle forward a bit, there's the hole, and yo, start that there. Oh, here it comes. Ah, that's so cool. See that oozing out there? So I might bring, oh no, I won't touch the camera. But, not that you should move this during the experiment, but I'll do it just for the sake of the camera. See that water oozing out there, out the side. I mean, not water, soap, my mistake. So, that's going to take quite a while to reach down to our empty line. Oh, it looks so cool the way it's coming out. This is going to be a really fun thing for students to explore. Oh. We're already at over a minute. I could have used things like honey, could have used, actually my nephew suggested I use custard, which would have taken quite a long time. I don't think a teacher should probably choose to use custard in the classroom, because maybe a concern to think about is how long really viscous liquids are going to take. Ways you can control that would be the fill line could be less high. The problem with that though is then the water is going to run out super fast. It's going to be difficult for students to time that. So I did, by design, pick these levels. They are completely arbitrary. This is sort of the perfect amount of fluid. It's maybe about 300 ml to get a quick time on the water as the less viscous fluid without it being too quick. But then to get quite a lengthy time on the soap. So the stream has slowed down quite a bit now, obviously as the pressure is dropping. So this lesson is not about pressure, but as a teacher, maybe be prepared for questions about why does it slow down as it reaches the hole. These are all really cool questions that are kind of open-ended, and as I said earlier, can lead to explorations, whether that's in the same year or the same body of lessons, or down the track in high school. If students want to continue with physical physical sciences. But for now, it's the learning outcome around this is very much just about how viscosity, or the viscosity of liquid, affects the rate at which it flows. This is actually also super beautiful and mesmerizing, so I think that's a really good quality of this test in a classroom context. Oh, so it's quite slow now. We've also got quite a clear meniscus too for this fluid, so it could be worth having a discussion before this lesson about meniscus and where we measure when we're using increments like this on a bottle or a clear vessel. So that meniscus is almost at that stop line. I'll get my finger ready. And not quite actually. And this is where you can see the level of my table is not perfectly spot on, but I don't think it's going to impact the accuracy of this test in a way that worries me. I think that's that, and call it. We've got 6 minutes and 13 for that one. So I'll put that down, 6 min, 13 seconds. Awesome. I'll be right back after I've cleaned this up and set up for our next one. Okay, I'm back. That took a little while to clean them up, so it could be a good idea to have multiple bottles with the same hole and clean up at the end. So, and as you can see, I actually saved a lot of the soap. So now we're going with oil. So again, we've got to take the hole so we can pull it up. Over that hole, nice and tight. Alright. And I'll face the hole somewhat out. And now we're time for liquid number 3, oil. So, holding my little finger over the thing, I'll fill up to the fill line. Now it looks like I don't quite have enough oil, so I'll just go inside and grab some. I've also got that tape is not holding, so what I'm going to do is put the cap on. And put it on the side, just so it doesn't escape while I just grab some oil BRB. Alright, so I've got some more oil. It's a different kind of oil. This is rice bran and this is olive oil. It probably is just best as a point of practice to probably fill up oil, but for the reasons of this experiment, it's not going to cover up everything. Alright, there's our fill line. Got to zero my stopwatch. Yep, alright. This might be good to have more than one person doing this. And here we go. So I lost probably a bit of a second at the start there, but I think I lost the same time doing each one. Another reason why repeating this test to get more accurate results. These are all discussions that the class can have during this test. So yeah, that went a lot quicker than expected, and I forgot to top the time there, so I'm actually going to do it again. That was 20 seconds, but I think it came out much quicker. And again, it sort of just stops. So instead of tape this one, I might just hold my finger on it and fill it up with oil. There we are. Okay, so zeroing my watch again with my oily hands, and I'll come around. Now we're ready. 1, 2, 3. And now I'm keeping an eye on the time this time. And stop. We've got 12 seconds on that one. So that's fantastic. And I can just let that keep dripping out there, and I'll put 12 seconds down on my paper. Great. Thanks for hanging around with me for this experiment. Now I'm gonna go clean up. Okay, I lied. I'm not cleaning up. So, from this point in time, we've got the independent variables of the three liquids giving us the dependent measurement of time. So to add another variable in that's when we've got our other bottles of different diameters. And so this test can be repeated with bottles. With this one is 3 ml, and then I've got a 7 ml hole as well. And so that'll give us obviously very different times. And with all those together, the idea is to then go and plot them on a line graph. And then ask the students to use that graph or modeling to then predict the outcomes of a test before they do it. So yeah.